Assalamualaikum guys, today we are going to see how to plot complex exponential function, but this time discrete time complex exponential function, and we will also plot its 3D. So as always, the first thing we are going to specify is the values at the independent axis using the line space function. Its argument, first argument is going to be the minimum value, the second is going to be the maximum value I want in my independent axis, and the third is going to be the number of values I want including them, okay, in between. Okay, the next thing is to define the function, which is amplitude into exponential power of sigma plus omega, and omega is the imaginary part, and in place of omega we are going to use as we know omega equals to 2 pi f. F is frequency, and as we know this is imaginary part, and to represent it as imaginary part in Matlab we use I, and it's convenient to use 1 with it, okay, and this whole thing is multiplied with t. Okay, the next thing to do is to specify the values for the things that I have used in my function definition, which is first of all amplitude, let it be 0. You can specify any value to it, and the sigma, let it to be 0. Okay, let's first see the value, the behavior of this function for sigma equals to 0, and its frequency. Let's say frequency equals to 2. Okay, the next thing is to create a window in which I'm going to plot this user function figure, and for 3D plot I will use the function stem, and its first argument is going to be the independent value. Here actually this is n, and next is the real part of this function, which I will get using the method real, and the imaginary part of this function that I will get using the method image. Okay, then second thing I'm going to do is to plot 2D plots. Okay, to plot its real and imaginary parts in 2D plot. For this I will use the stem function, and in the first one I will pass the values of the independent axis and its real part. In the second one I will pass the values of the independent axis and the imaginary part of this function. Okay, now let's see what happens. So first of all, figure 1. Here is figure 1. I think these values, let's increase the number of values in between so that we can clearly see its behavior. Let it be 20. Okay, let's increase it a little bit more. Let it be 100. Okay. So here we are. Like this. Okay, it's like this. Okay, you can see that for value of sigma equals to 0, it have this kind of function, like, okay, increasing, then decreasing, then increasing, then decreasing. Okay, it's constantly moving. You can see that it's constantly moving like this. This is just see the dots, that how they are going like this. Okay, with a constant rate it is going on. Let's see its real and exponential part. As we know that its real part is going to be like the cos function, and as we know that at 0 value of cos is maximum, and this is same like its real part, which was figure 2, is same like the cos function. And let's see its imaginary part. which was going to behave like a sine function, as we know that at 0 the value of sine is 0 and it's just like the curve of sine function. So guys, this was the behavior of our exponential function, complex exponential function with the sigma value equals to 0. Let its value be some a positive value. Now see what happens. Okay, the figure 1 is going to be the whole function. Okay, in case of positive value, we can see that its values are continuously exponentially increasing. And we can see that it is exponentially increasing. And let's see its imaginary real part separately. Figure 2 is its real part. As we can see that at maximum value, okay, it is maxima. Or you can see that this is just like a cos function, but which is exponentially increasing. And this one is imaginary part of this function, and we can see that it is just like sine function, which is exponentially increasing. Now let's see its behavior for the negative value of sigma. Okay, let's first look at figure 1, which is the 3D plot of this function, this whole function with its real and imaginary part. And as we can see that it is exponentially decreasing. And let's look at its real part, which is figure 2, and we can see that it is just like cos function, as cos is maximum 1 at 0, just like cos function, and it is exponentially decreasing because of negative value of sigma. And this is its imaginary part, which is 0 at 0, just like as a sine function, and it is exponentially decreasing because of negative value of sigma. I hope guys you have liked this video and your concepts regarding discrete time complex exponential signals are functions are clear, and now you know how to plot how to plot a complex exponential function and how to plot their imaginary and real parts separately, and how to plot this function in 3D. And please kindly subscribe my channel. Thank you.